Okay, hi everyone. Welcome back to the AI/ML roadmap series. And currently, we are discussing about the Python fundamentals. And yeah, let's do a quick look what we have learned till now. So we have learned about the basics. We have also learned about the different variable and the data types. We have talked about the number data type, booleans, operators. We have discussed strings in Python. We have discussed about the range function in Python, and we have talked about the data collections like lists, tuples, sets, and dictionaries. And then we talked about how we can take input from the user. We have talked about if-else statements, if, elif, etc. Then we talked about the loops. There are two type of loops, which is for loop and the while loop, and we have discussed how to create them, how to work with them. We have discussed about the break statement, continue statement, and the pass statements, how we can use those in the loops. Okay, now today we are going to discuss another topic and maybe more topics, so one of which is Python functions, right? So we have been using this. I think I remember somewhere we did make a Python function, but let go into details. So what are functions? So functions in Python are usable block of code that performs a specific task. Okay, so let's say you want to do a sum of two numbers. Okay, let's say a plus, so for example, let's say you have number 1, b equals to number 2, and you want to do c equals to a plus b, right? And you want to print c, for example. Okay, now you want to take the sum of, let's say, 3 and 4. Okay, so you need to do the same thing again, right? And let's say now you want to do the sum of 5 and 6, for example. So you need to do this thing again. So in Python we have something called a function. So how we are doing this repetitive work, what we can do, we can create a function def. This is a keyword. This is how the backend knows that this is the beginning of a function. Let's call it a sum function, and yeah, and let's pass those a and b as a variable, and we can simply do c equals to a plus b. And now when I call sum 1 plus 2, it will print me 3. Now if I call this sum plus, let me quickly do this. If I do something like 3 comma 4, it will print me 7. Okay, sorry, we'll talk about it why it is printing none in a little while. Okay, 7. Now if I call it with 5 and 6, it will print me 11, right? So this whole thing, which is taking like 1 2 3 4 8 12 13 14 line of code, this can be done in simple 3 line using a function, right? So what is a function? It is a reusable block of code that performs a specific task, right? So yeah, so basically it helps to make the code modular, organized, and easier to maintain. So for example, in future I want, instead of doing a plus b, I want something like a plus b minus 10 or something like that, right? Instead of printing c, I want to print something like this. So I just need to make the change in the function, and when I run it, it will automatically, it will automatically get changed for all of these because it is calling this, right? So I don't need to go and update each, right? So this is how these functions are modular and organized, and they are easier to maintain basically, right? So how we can define a function, we have already seen here, right? There are a few more things. Functions with parameter, function with no parameter, function with return values, default parameters, keyword arguments, variable length arguments, nested functions. Okay, let's see how we do it. And just remember one thing, whenever you are working with functions, try to understand them, because this is something which gets used. So this is the functions. When we say functions, this is a modular entity that will define your every project you will work in, or everything you'll created. And if you if you want to see the the libraries that the Python 3 package, so it is also written in Python. So if you see, so it also has like all the functions, and when you combine these functions you become modules, then it became packages, right? So it's very important to understand how how functions work in Python. Okay, so let's start. So how to create a function, we have already learned that. For example, def, we can create a function func, and let's say it is only doing print hello. Let's say it's doing hello world. Okay, now how to call it is, we can simply call this func, right? And no matter how many times we call it, it will print me the output, right? Now you see this function name, so there are some rules to it. So you remember when we were learning about variables, to create a variables, we talked about some rules of creating a variable, that a variable cannot start with 2, right? We cannot have something like 2 is equals to 10, right? We cannot have something like start with a keyword. So similar way, in functions also we have some rules, that our function name should start with a letter or with an underscore, and it cannot start with a number, right? So yeah, so these are the rules that we have, and you should follow it, obviously, right? Next we have that why we want to use functions. We already talked about it, that because it is modular, because it is easier to maintain. If there is a change you need to do throughout, you can just make the change to this particular. So for example, here I want to, instead of hello world, I want to print hello nation, right? If I want to do hello nation, so I'll just make this change here, and every time I'm calling it, it will print that only, right? So that's how you can use functions, right? Okay, then we have something like called a return values. So let's see what happens here. So for example, I create a function which is uh, doing sum of numbers. Let's say sum numbers, and I have two numbers, and what it is doing is printing the sum of two numbers, right? So now let's call it. So what it will do, it will print me. Okay, something is wrong. Okay, so some number is a kind of a known function. So let's change it to something else. Some function underscore sum. Let's make this name to something like this. Okay, now when I run it, a comma b, or let's run it on 1 comma 2. So what it will do, it will print 3, right? Now what if I want to store this into a, let's say, a third number c? Would it work? Let's try it. It will throw. Okay, it will. Now let's try to print this fc. See what happens. It will print none. But what I want to print, what I want to store in c is sum of it. So how I can do it is, I can use a return keyword, and what I need to return is simply the sum of a plus b, right? So once I do that, you see, it will, the c is 3, right? So that's how we can use the return statements, right? by default it returns none. So like we see, if we do not have this return statement here, so by default any function returns none, right? But the moment I put something like return a plus b, it will return 3, right? Now similar how we discussed the pass statements in for loop, if similarly here also we have pass operator. So suppose you have defined a function func and you don't know what to do inside it, so you can just simply create a pass holder with the pass. So if you run it, so and if you call this function, so nothing happens, okay, because it's not doing anything right now. Okay, so this is how you can create functions in Python. Okay, now we'll talk about function arguments. Okay, so when we are writing a function, let's say let's write something like func def my function, and I'm passing a variable, let's say. Okay, and let's into that I'll just do print number, for example, a. Okay, so this def is the start of a function, then this is my function name, and this a is called as an argument. Okay, so basically everything which is passed to a function is called an argument, right? So this is how many we can pass many arguments inside this function. So whatever is passed inside these parentheses is called a argument. Okay, right? So let's quickly call it, run it. So let's call it with, let's say 1, so it will print me number 1, right? Next we have is parameters versus arguments. Most of the people think they are same, but there is a little difference between them. Okay, so the parameter is something which is listed inside the parenthesis in the function parameter. So this is the parameter, and now the value which is actually sent to the function, this is 1, so it will be an argument. Okay, now let's see here. So here this 1 is a argument, right, and this a is a parameter. Okay, so this is small slightest difference, but just try to remember it. Like it's not a big deal, but yeah, try to remember it. Okay, now right now we have passed one argument, so you can pass multiple arguments as well. Like you can pass as many arguments as you want. For example, I have a function which is, let's say a plus b. I can pass 2 arguments, and sometimes what happens that let's say I pass 3, one more, and I pass here 3, but I don't want to do anything with it inside, so it's okay, like you can have something like this. But for example, you have defined a function like this, and sorry, if you define a function like this and if you are running it with something like 1 and 2, let's see what happens. So it will throw an error because your function expects 3 arguments, right? See, that's the difference. Okay, now we'll talk about the default parameter values. So we know what is a parameter mean is this is a parameter, right? So for example I have something like a for example, I have a function like my function, and I have two parameters a and b. Now what if I don't want to pass the value of a every time I'm calling a function, right? So what I can do is, so if I do something like 2 comma 2, so what will happen is, okay, wait, 2 comma 2, what will happen, it will give me 4, right? What's wrong? Okay, so yeah, one thing to remember, I'll talk about it. Okay, yeah, so 2 plus 2 is 4, right? Now what if I just want to pass the value of a, and I just like the value of b has some default value to it. Okay, so I don't want to pass it as an argument. So if I pass just 2, so how it will get mapped? So I should get an answer of 3. So how it will map? So it will map to 2, it will be mapped to a. Now there is no parameter afterwards, right? So it will just take the default value of b, right? But let's say if I have something like this, and now if I run it, it will throw an error with that one positional argument is missing, right? So you need to define it as b equals to 1. So if I run it, so it will be something like 3. Okay, this is how we can do it. Now next we have is keyword arguments. So for example, same, let's have something like this. Okay, something a function same a is equal to a sum function, right? So now instead of like if I call it something like this, it will give me 2, right? The same way I could also call it as my function a equals to 1 comma b equals to 2, let's say. So the answer should be 3. And I could also call it as b equals to 1 and let's say a equals to 2. So it will b will map to this, a will map to this, so the output should be 3. So if I'm passing the key with the argument, then it becomes a keyword argument. Okay, now there is something called as a positional argument as well. So let's say I have defined this function. Now if I run it, I'll get an output of 2. Let's have it 2. I'll have an output. So a will be mapped to 1, b will be mapped to 2. So let's here also print a comma b as well. Okay, let's to see something. Okay, 1, 2 and 3. Now let's, if I do something like 2 comma 1. So let's see what happens. If you see, this 2 is mapped to a and this 1 is mapped to b, right? So a becomes 2, b becomes 1, right? So this is what we call as a positional argument, right? Now how can I mix these? Till now I have understood how to create a positional argument and I know how to create a keyword argument, right? So now what if I want to mix it, right? I can also do that. For example, let's say let's create a function. Okay, def my func is, let's say, pass a, b and c, and let's just print the okay print. Okay, now when I call it a, I call it b, c. Okay, these now I am calling it as a positional arguments. Okay, and you know how to create a keyword argument like this. Now if I want to mix, so how I can do it is, I could do something like for function, let's say 1 comma b equals to 2 comma 3. So what will happen, this 1 will be mapped to a, b will map to b and 3 will be mapped to c. Let's see what happens, if it works or not. I think it will not work, right? The reason being that a positional argument cannot follow a keyword argument, right? So I need to define it something like c equals to, I need to define it something like c equals to 3. Now if I run it, it should work. Something wrong. Okay, yeah, I forgot to. Now let's see, right? What if I want to pass only the positional arguments? So how I could do it is, we have discussed that positional arguments is where we can just pass them by position. So ABC will pass them 1 2 3. So A1 will be mapped to A, 2 will be mapped to B, and 3 will be mapped to C, right? In the similar way, if I want to just allow positional arguments, how I could do it? For example, this is my function. Now to make it as a positional argument, I could just add simple like this. So now if I do something like this, okay, wait, if I do something like this, it will work, right? But what if I do something like this? Let's see if it works or not. You see, it will throw a type error, right? That means that it will not allow. But what if I remove this from here? Then it will work fine. See the difference? Okay, how I can make our function as a positional or only allowing positional arguments. Similar way, how I can also make my function only to accept the keyword arguments. Similar, let's create this function. Now instead of this, I could just add a little star at the beginning. So the moment I does this, so if I run something like this, it will fail. It will fail with an error. Okay, no, sorry, this will pass because these are the keywords. So if I pass the positional argument, so it should throw an error, right? Okay, got it. This is how you can pass the keyword only arguments to your functions. Okay, these are the little things. You might not use them right away, but these are good if you want to create a good good module. And like, it depends on your requirement how you want to define it, but it's good to know these things, right? Next is, if I want to, let's say, combine the positional arguments and the keyword only arguments. Let's see how I could do it. For example, I have created a function, again same function, which has some A, B, C, D, E, okay. And what I'm doing, I'm just printing it. For example, here A, B, C, D, E, and F. Okay, so now if I call this function my func, so right now I could call it as a, let's call it as a positional arguments. Okay, I could also mix it with positional and the keyword only, positional and the keyword. So I could do something like this. F. Okay, I could do something like this as well, and it should also work. Now I want to combine my positional only and the keyword only. So what I could do, so let's say I want to make C and D as a positional only, and I want to make E and F as a keyword only. Okay, so what I could do is I could simply add something called a star. this will make all the whatever we have after as a keyword only. And what I want to make these as a positional only, so I'll add the hyphen. So now if I run it, let's see if it works or not. It will fail. See that my function takes 4 positional arguments but 6 were given, right? So this will fail. Let's try for the next one as well. Let's see what happens here. It will also fail because my function takes 4 positional arguments but 5 positional arguments were given, right? Now let's correct it. If I do something like equals to 5, let's see if it works or not. So it will work, right? Let's see one more thing as well. You see the error we are getting is my function take 4, so let's do make this as 5 and do d equals 4. Let's see if it works or not. See, it will not work, right? So you need to be careful. And yeah, this is how you can combine your positional only arguments and keyword only arguments. Okay, yeah, okay, I hope this is clear. I know like it's a little bit too scattered, but just try to grasp whatever is happening. So basically this is how you can declare a function, how you can call it. The variables passed to the function are called parameter, and the values passed while you are calling the function are called arguments. You can have two type of arguments, which is one is positional arguments and second is keyword arguments, right? You can also have default parameter values as well. You can also have positional only arguments. You can also have keyword only arguments, and how you can combine these arguments we have also seen that, right? So this is good. Now we'll talk about something called args. So what we have discussed about, so let's start. So while we were doing this, so what we have understood, so def, let's say func is having a comma b, and we'll just simply printing a comma b. Okay, so to call it I need to pass both arguments, right? It will only work if I pass both arguments. For example, if I do something like func1, so it will throw an error, right? Now for example, I don't know how many values I am passing, okay, how many arguments I am passing. So what I could do is I could simply make the function as something like star args, okay, something like this. And I could do here, I could say args1 and args2. So I'll just show you what happens. Okay, so the moment I pass it as something like this, so okay, I'll get an error index out, okay, 0 and 1, sorry. Okay, the moment I passed something like this, so what will happen when I'm passing 1 comma 2, it is taking it as a tuple. Okay, now we know how to work with a tuple. You can simply call them by indexing, right? This is how you can do it. So this arg is called as a arbitrary arguments. Okay, now we have understood how we can pass any number of positional arguments. Okay, but now let's say I want to pass some keyword arguments as well, right? So how we can do it? We have understood how we can pass the arbitrary arguments. Now let's see how we can pass the keyword arguments as well. For example, let's take this one as well, this one only. So instead of arcs you could do something k, just add a k. So let's try running it, let's see if it works. It will not, it will fail. Okay, fail with a different error. Let's say I say something like, so this is how you define a argument, sorry, keyword argument with a double star. Okay, so if I do something like this, it will throw an error. So the error is function takes 0 position argument but 2 were given. Okay, now how I could, instead of this I should pass it as something like this, func name or a equals to 1 comma b equals to 2. So here also how I can use it, a and b. Let's quickly run it and see whether it's working or not. Right, this is how you can define your key arguments. Okay, sometimes it happens that you have some defined like you have some uh, arbitrary arguments and you have some keyword arguments as well, like we were doing earlier, how we can combine the positional argument and the keyword argument. Similarly we can also combine these two as well. So for example, I have a function func which is taking a variable a, then it is taking some arbitrary arguments, and then it is taking some keyword arguments. Okay, so how I can pass it, so while calling it I will have something like 1, I'll have something like 2 3 4. So now what will happen, so this 1 will be mapped to a, right, and the keyword arguments, so you see x and 5, they will be marked as a keyword argument, and this 2 3 4 whatever it is between, it will be marked as a arbitrary argument. So let's quickly verify it. You see, so 1 is mapped to a, args is a tuple, right, and this coargs is a key value pair, right. X is the key value is the 5 and y is the key and 6 is the value, right. This is how you can do it. Okay, now one more thing that we'll talk about is how we can unpack list with star. For example, we are defining a function def func. I am passing the few variables a, b, c. Okay, and I'm just printing print a comma b comma c. Okay, while calling it I can do something like func 1 comma 2 comma 3, right, and if I run it, it will work fine. Or I could do something like list 1 equals to 1 comma 2 comma 3, and I could just simply call it like this, func star list 1. Let's see what happens. See, works both ways. So this is how you can unpack your list with arguments. A similar way you could unpack your keyword, you can unpack your dictionary with double star, because double star is keyword, right. So this is how you can do it. For example, you have a function, let's take the same function. Okay, now let's say you have a dictionary, let's say dict1, which is something like a value 1, b value 2 and c value 3. Now if you run it something like this, double star and dict1, so it will also work, right? This is how you can collect your arguments and unpack it. So this is something will help you while you will work with some different data structures when you don't know how many values you are getting, right? So this is how you can work with it. So yeah, next we have is scope. This is something we have discussed in the very beginning, where we discussed with functions, okay, if you remember. So scope of a function, yeah. So for example, I have created a function def func, and now I have define a variable a equals to print a, right? So now if I run it will print me 1. Now if I try to print a, so it will, okay, let's rename it to something, because I think we have a defined somewhere above, number x. So yeah, so it will throw an error, right? Because the scope of this number is within this def, okay. Now for example, we have something like this, number x underscore 1 equals to 1. Now we define it as def func, we'll do number x underscore 1 equals to 4, and if we try to print it, number x underscore 1, and if we try to do this, let's see what happens. So when I'm printing here, so it will print 4, but when I'm printing here, it will only print 1, because this change happened inside the function, okay. So this is the local scope. Now for example, if I just remove this, I hide it, now it will give me both 1, because the number 1 is 1 here and the number 1 is again 1 here, okay. So this is how we can scope our variables, and same with the functions as well. For example, let's say I have created a function x, I create a function my underscore function, and I have defined a variable x equals to 10. Now I have created another function inside it, def in a function, and I'll just print 10 here, okay, and I'll do something here as well, exit inner, for example. No, sorry, I'll print in my func, for example, okay, in my func. So I need to call it here. Now I want to call this function, so what will happen? See, this is how this function inside a function works. So right, so I have called this function. What it is doing, it is defining a variable 10, then it is defining another function, which is this. Now what I am doing, I am calling this function inside a function, right? So when I am calling this, it will call this, right, and it will print 10, and then it will printing this. Now what if I try to call this function? Let's see what happens. So it will throw an error, right, because the scope of this function inner is between this, is inside this function only, right? So this is how it works, right? Okay, next we have talked about the global scope. We have already discussed it above, but let's take another example, same example. So for example, I have created a variable known as variable underscore 1, which value is 100, let's say. Now I create a def func, I create a function called func, and what it is doing is just printing this variable, for example. Okay, okay, so you see this variable value is same here and here. Okay, now how we can define a global variable? For example, something I have defined in, okay, let's take this example only. So I have defined something like this, and in the inside let's say I am changing this variable to 50. So now when I print it, so this will show me the value 50 and this will show me value 100. Okay, works. Now what if I redefine it and say something like this? Let's call it variable 2. Okay, I define something like this. Now if I run it, so this will print me 50, but this is something that will throw an error. Let's quickly say it. It will throw an error because this variable 2 is not defined anywhere. It is defined inside this function, but its scope is limited. Okay, so how to make this function, this variable that is defined inside the function available for rest of the code? How we can do is let's say I just copy paste it. I could do something. I have a variable something called global, and I'll define this variable as a global, right? And then now let's try the same thing. Let's make the value as 50. So now I have called this function, it will go there, so it will create a global variable, it will assign a value of 150 to it, it will print it. Now I have called this variable 2, so this variable 2 does not exist outside of it, right? But since inside this def function I have created this variable as a global, so it should be able to retain it. So let's quickly verify it, and if you see, it worked. So this is how you can define the scope, your function scope. Okay, so I think we have covered almost everything related to the functions. We've understood how to define a function, how to call it, we have understood the functions with parameters, how to get a return value, we have understood what are default parameters, we have understood what are positional arguments, keyword arguments, how to combine those. We have also learned how to pass only positional only arguments, keyword only arguments, and how to combine those two as well. Then we learned about the variable length arguments, passing star arcs and with passing double star arcs, right? How that works. And then we have also learned about the nested functions. We have learned about the function scope, how you can do it, how you can create global variables inside it, and how you can retain it outside your functions as well. Okay, so this is what all functions is about. Next we'll talk about very important things, which is decorators, lambda functions, recursions, and generators. So these are the things as you'll as you will go more into writing code or modules, you'll see that these are used very frequently to ease everything. Instead of writing hundreds and thousands of lines of code, we can use these you can use function for the reusability purpose. Similarly, we can have decorator, lambda functions, generator, and etc. to ease and to reduce the number of lines. Okay, so we'll start with lambda functions. So lambda functions are small anonymous functions written within a line. So you don't need to define like a def or define a function like creating a def, then defining a function name, and so on and so. You can simply call the lambda functions. Okay, so let's start with it. So how we can define it? Basically, you this is a keyword lambda, and then you define some arguments whatever you want to pass. Let's say I want to pass A, B and C or something like that, and then you want to what you want to perform, basically the expression. For example, let's say I want to do a sum of two numbers. Okay, sum of two numbers. So one way is to do something like def func a comma b print a plus b. One way to do is this, right? Now when I call this function with, let's say 1 comma 2, I'll get something like 3, right? The other way to do it is we can call a lambda. So how we can define it is lambda. We can pass the arguments, which is here is a comma b, right? And we can mention the expression, which is what I want to do is I want to do a plus b, right? This is something I want to do, right? Now you need to store it somewhere, so I'll just quickly name it as x lambda equals to, okay, lambda, I missed the d, so this is how you can define it, right? Let's quickly see if it works or not. So now how to call it? So we'll call it something like, we'll call this where we have defined it, so lambda. And now what does it require? It requires two parameters, which is a and b. Let's pass that 2 comma 3. So let's see what happens. So what it will do, we'll call this x lambda, which is a lambda type. Okay, so I'm passing two parameters 2 comma 3, which is a will be mapped to 2, b will be mapped to 3. Then what we are doing is we are making an expression which is doing just addition of these two. So we are just adding 2 plus 3 equals to 5, right? So this is how you can define the lambdas. Okay, so why to use lambda? So basically, instead of creating functions and things like that, you can just simply define. So if you have something you want to like do small, then you should use lambda functions, right? This is how we can do it. Now lambda has some built-in functions. So what are the, so why to use it? We discussed that they are anonymous, and you don't need any reusability with it. You just need it for some calculation for some short amount of time, right? So if you have something like this, you can go for the lambda functions. Okay, next with lambda we have some built-in functions. Okay, so what are these? We have three. One is map, second is filter, and third is sorted. Okay, so let's see one by one. So let's say I have a list num1 equals to 1 comma 2 comma 3 comma 4 comma 5. Okay, now what I want is I want to create a mapping. For example, let's do something like I want to add 1 to each number. Okay, so what I want is I want a list with output 2 3 4 5 6, something like this. So how we can do it? So I could do something like lambda 1 equals to, let's define our lambda first. Lambda x equals to 1, right? And I could just map it. This to our num1, right? And let's see what happens if I do this first. Lambda 1, it will create a map object. So I need to map this object. Let's say I want to convert it to a list. So I would do something like this. Okay, see, this is how we can use the map. So what I am doing is in the map I am passing my this num, and for each value I am incrementing it by 1, right? This is how you can do your map function with lambda. Okay, now next we have filter. Similarly, let's say I have the same num list, and I want to find the even numbers. Okay, so I want a list of even numbers, so I should get 2 and 4, right? So how I can do it is lambda 2 equals to, let me first create the lambda, which is lambda, let's say x. What I want is it should give me x if x for each value if it is divisible by 2, right? So the remainder should be 0, right? This is how my lambda will work. Now on what I want to work it on num, right? And what I want, instead of map, let's see what happens if I do map, and let's see what happens if I do filter. Let's see for both. Okay, yeah, okay. So if I run it, let's see what happens with map. So with map it gives me the value. So is x percentage by 2 equals to 0. So is 1 divisible by 2? False. Is 2 divisible by 2? True. Is 3 divisible by 2? False. Is 4 divisible by 2? True, right? Now, but what I'm interested in is in the list, right? So what I can do, I can just simply mention here filter. Okay, so what it does, it will return me the list of items for which this function returns true. Okay, so this is how the list work. Next one is sorted. So for example, how sorted work is, we can sort with a lambda. The lambda can behave as a key. So for example, I have created a list of this student, which is a list of tuples, right? So now what I want to sort this list by, let's say I want to sort this list by the age. Okay, so how I can do it is, I can use sorted. I can pass this student, right? I can pass this student. Then for the key, what I can do is I can pass this lambda x1. So for each element, x is each element, so x would be this. So what is 25 is 0 1, so first element, right, with an index of 1. So now let's run it. So what will we have? So we will have something like this, because it is already sorted. But let's say it is something like this. So what we'll have, we will have something like 29 30 45. Let's say I want to sort it by the name, so we'll just have to do something like this. Sorry, we just need to pass the index as 0. Now if I run it, what we'll have something like John, Paul and Ruhi, right? This is how we can sort using lambdas. So this is how lambda works. When to use lambda? So if you don't want to create the whole functions or something like that, and you just need it for the little amount of time, right? You can use lambdas. Okay, so this is how it works. Pretty simple, but very useful. It gets used very oftenly, and yeah, you will see these used very often. Okay, next, the second thing, we'll have recursions. Recursion is something like, you have also heard it multiple times in real life as well. So recursion is something when a thing called itself multiple times. Okay, so similar when working in Python, recursion is a function that call itself, right? So often used to solve problem that can be broken down into several sub problems. Okay, now let's see how it works. Okay, so let's see how the recursion works. Is, for example, so let's take a simple example. So for example, I need to I have a list. For example, let's say I have a list. Okay, let's say the list is something like this, my underscore list equals to, or I can have something like list 1 equals to 1 2 3 4 5 and 6. What I want to sum of all elements. So there are multiple ways to do it. So I with list I also have a direct function which is something like sum, and I could just pass my list and it should work fine. Let me just run it, so it will give me the sum. Okay, this is the one way. Another way is you could do something like a loop, right? For element in list 1, what you can do is you can create a C which is just adding element, right? Sorry, element, and then you can just print it. So let's initialize the C to 0. So this will also give me the same result. Okay, something is wrong. Type, okay, list 1. Okay, let's run it, so it will also work. Now the third way you can solve this is using a recursion. So let's see how you can do it. For example, you have defined a function def. You have created something like sum of list, and what I'll pass in this are numbers, right? So you need to define a base condition, basically when to exit. So you can say something like this: if length of numbers equals to 0, basically all the numbers are summed, right? So just return 0. Otherwise, what you should do, you should add the first number and then you should call the list on rest of the number. Okay, let's see how it works. So I'll simply call it on sum of list 1, right? So let's see how it works. So what will happen? Yeah, so let's print it here only, print numbers. So let's see what happens. So initially when I call this, it will pass all the list, right? It passes the complete list 1 2 3 4 5 6, right? Then it will check whether the length of the numbers is 0 or not. It's not, right? It has 6 numbers, so it will go to else. So what it is doing, it is adding the first number and calling this function again, right, with the second and the last of the from second to last element. This is how we do slicing, right? So now it get called on 2 3 4 5 6. So when it goes again, so it is called on 2 3 4 5 6. It checks again whether the length is 0 or not. It's not, right? So now what it will do, it will add the first element, right, which is 2. So it will become 3. So let's see what happens. So initially when I called it, it will work with this, right? Okay, just give a second. It will go with this. Now it's the length 0? No, right? What it will do, it will add the first number 1 plus, and it will call this sum on the list with this, right? Make sense? Now second time when it calls the function, the list become this, and now it will check the length. Is length 0? Again it's a no, right? What it will do, it will take the first number, which is 2, and call the sum list on rest of the list, right? It will call the sum on 3 4 5 6, right? Now again the third time it will call this function. So we'll have the so the list we have right now is this. something like this. Okay, we'll check again, is length equals to 0? No, है ना? So what it will do, it will again 3 plus, and it will call the sum, this function again, and on list with 4 5 6, right? Now it will call this sum again and with something like this, right? And length equals to 0, again it's a no, right? So it will go to the else block, which is doing 4 plus, it is calling this sum list on the rest of the list, which is 5 6, right? So again this sum got called, so we'll have something like 5 6. Now this length, is it 0? Again no, again no, right? So what it will do, 5 plus, it will again call this sum list method on 6, है ना? Now again it will go here, so 6 is length equals to 0, again it's a no. Then it will do 6 plus, it will call sum list on an empty list, right? Then it will go again here, now the list is empty, so here it will check length equals to 0, this should be true, right? And it will return 0, right? So now how the calculation will work, what it will do, 1 plus 2 plus 3 plus 4 5 6. So what it will do is 1 plus 2 plus 3 plus 4 plus 5 plus 6 equals to 21, right? This is how the recursion work, right? And yeah, similarly everything that you can do with loops or something like that, you can also do it with recursion, basically, right? If something needs to be done multiple, like the same thing needs to be done multiple times, you can simply call recursion. Okay, similar examples are factorial and the Fibonacci. They are the like known examples of recursion, so you can also try these two as well, right? We can try the factorial one. Let's do the factorial one. So let's see how factorial works. Okay, so what is factorial? So if I say I want to do factorial of 1, so what is 1, right? If I want to do factorial of 0, so factorial of 0 is also 1. Okay, remember not to remember. Okay, if I want the factorial of 2 is 1 into 2 equals to 2. Okay, I want to do factorial of 3, it is 3 into 2 into 1, which is 6. And similarly, if I want to do factorial of n, it is something like n into n minus 1 into n minus 2 into till into 1, right? This is how the factorial works. Okay, now if I want to write a recursion for it, let's first write a loop for it. Okay, so how I can do it? So for example, if somebody says get the factorial of 4, for example, so how I can write it in a loop? For I in range from 1 to num. Let's see if it works or not. If I do from 1 to num, so what should be the factorial? Let's quickly see. 4 into 3 into 2 into 1. Okay, so what we have, 4 to the 12, 12 to the 24. Okay, so if you see, this is how we can do it, right? Using loops. The second way we could do it is using factorial. Let's create a factorial for it. So this is how we can do it, right? The same way how we were doing earlier. So let's see how it will work. So let's do it for, sorry, print, just write for factorial of 4. Okay, similar way how we have decoded for here. So here also, so it will start with 4. First it will check the base condition. Is 4 equals to 0? No, right? So what it will do, it will do 4, sorry, it will do 4 into, it will call factorial again with 4 minus 1 is 3, right? Now it's called with 3. It will check whether 3 equals to 0. Again it's a no, right? So it will do 3 into factorial, it will call factorial with 2, right? Again it will 2 is 2 equals to 0. Again no, again no, right? So it will do 2 into, it will call factorial with 2 minus 1, which is 1, right? It will call factorial 1, it will call with 1. So 1 equals to 0. Again it's a no, right? Now it will call 1, it will call factorial with 1 minus 1, sorry, 1 minus 1, which is 0, right? Now it will go here, so it will call with 0. So is 0 equals to 0? It becomes true, right? It becomes true, so it will return 1. So we'll have something like 1 into 1 into 2 into 3 into 4, which is 24. So see, so this is my base condition. For example, if I make return 0, so what will happen? It will, the last return is returning 0, so 0 into everything is 0, right? So the base condition is important, and then your factorial recursive condition. Okay, so this is how you can work with recursions. Okay, next you need to understand something about the recursion depth limit. So Python has a depth, like Python has a limit how deep a recursion can go. So to check the recursion limit of your machine, you can just simply do import sys. So sys is a system module, don't worry how we are doing it, just it is defined somewhere. To use it in our workspace, I need to do import it, right? I'm doing this, and you can simply do print sys dot get recursion limit, right? Sorry, get recursion limit, right? So once you do it, it will show you the recursion limits, right? Suppose you want to change it, suppose I want to change the limit, so you can do something like this, and when you print it, so the limit will be changed to this, right? This is how you can go with it. Okay, so till now we have discussed what is a lambda, and we have discussed what is a recursion. Okay, next we have something called generators. Okay, so what are generators? Generator are the functions that can pause and resume their execution. Okay, so here the important keyword is yield. So whenever a generator function is called, it returns a generator object, which is an iterator. Like you can iterate through it like a loop or something like that. Okay, so let's quickly see how we have it. Okay, yeah, for example, how you define it, similarly like a function. For example, you have something like def my generator, something like this, and instead of doing this, you can just simply mention, okay, let's define a simple one. So you define a generator, and you can simply mention yield, let's say 1 yield, right? So if you print g, it will just print that this is a generator object. And how to loop through it? you could call something like a loop. So if I do something like for I in G and I do something like that, so it will print 1 2 3, right? So this is how the generator works. It allows you to iterate over data without storing the entire data set in memory. So that's the difference between generators. Okay, if you have noticed something, that here instead of using a return, it is using yield. Okay, so if instead of yield you return, if you mention return, so it will become a function instead of a generator. Okay, so this is how the generator work. Okay, let's see another thing. So if you let's say I define a function def func, it is doing, it is returning 1, let's say. So if I call this func, it will return 1, right? But if I do something like return, let's see if it works or not. So if you see, it will not work, because return can only return one thing, and after that it will just exit the function. But with yield, it just pauses it, and it can be called multiple times, right? Okay, so this is how you can use generators. So why we use generators is because generators are memory efficient, as they generate values on the fly, and they do not store it they do not store it in the memory, right? So in case you have a large data set, it is said to use generators. Okay, now for example, you have let's say you have let's create a simple generator which is create. So yeah, so you have something like, so how we were doing, how we are iterating through G using a loop, we can also iterate through a next keyword. So let's see how it works. So for example, let's take this, let's define it. Now if I called, for example, if I called, let's say we define this, so let's say I called something like this. So what it will have, with every next, it will iterate through it. So for the first next, it will return 1 2 and 3. Let me try to run it one more time. So it should throw an error because there are only 3 yield, right? So here it will throw an error. See, this is how we can use it with next function. Okay, next with generators. Okay, next is generator of expressions. If you remember how we have created the list comprehension, similar we can create the generator expressions as well. So how we were creating list comprehension is, we were doing something like this, is equal to, let's say I want to create a list with 10 items, right? So I could do something like this and it will create me 0 to 9. Let me, if I want to create with a generator, so what how I'll do, there's only one difference. So yeah, so instead of square brackets, I'll use parentheses. So now if I print it, so it will print a generator object, right? And you know how to iterate through it. You can do a for loop, or you can use a next you can use the next you can use the next function, right, on it. Okay, so this is how you can create generator expressions. We have understood the difference between two, and then we'll have something like we also have generator methods. So in that we have two methods. Okay, for example, send, which means you want to pass something to a generator from the user. If you want to pass something to the generator, for example, for example, you have something like def func. Let's say I've created a function which is doing something like c equals to yield. Let's see if it works or not. Okay, so I've created my generator. G is equal to func, and let's print this G. Let's see if it works or not. So it has created a generator object. So let's see what happens if I call a next method on it. So it should give me none because there is no yield, right? But now let me do something like g dot send. Let's say I send 1. So let's see what happens. So it will show me can't send no none value to a just started generator. Okay, I'll have something like this. So if I do this, I'll get something like this. So now how to correct it, how to correctly do it. So what I need to do, I created the G object, it works fine. Then how do I send it? So here I've created the method. Now here I need to print it somewhere. Let's say I do print C and can't send a none value to a just started generator. So I'm not sending a none value, I'm sending 1. So let's see again. Okay, sorry. Okay, so you need, let's see, we do something like this, yield 1. Okay, yeah, you need to do something like this. For example, now if we pass it, it works. We have created a func. Okay, so I need to do this. Yeah, see, it works now. Also, if you don't want to, let's try one more thing. Let's say I create a def func. I just do yield 1 and I do c equals to yield and I just simply print this c. Okay, and I'll call this with a generator with the function. So if I do this, let's see if it works or not. So again, it also works, right? So we know how it works. Okay, okay, so this is how you can do it, right? Okay, next method we have is the close method. So close method is something like the word says, is to stop the generator. So for example, like we did in this one, so if I do something like this, so it will print me 1 2 3, but if I try to do this again, it will do something like this, stop iteration. Okay, so instead of this I could do something like g dot, so if I do g dot close, so if I do this, so it will run fine. Or what if I do the first, if I print the first one, then I just close it. Okay, if I'll just close it, it will only print me 1, and if I try to print this next g again, it should throw me an error, right? Because I have already closed this generator, right? So this is how you can work with generators. We have understood how to create a generator with a yield keyword. We have understood difference between yield and return. We've understood why to use generators because they are memory uh, efficient, and we have understood how to create generator expression, the difference between list comprehensions and generator expressions. We have learned about two methods of generators. One is send and the second is close, right? So this is how you can work with it. Yeah. So the next topic which we have is decorators. So let's quickly go through some text about it. So decorator modifier extend the behavior of a function without changing its code. Okay, so what is decorator? So decorator is something that lets you add some extra behavior to the function basically. So for example, let's do something like, okay, yeah. So for example, you have a function. What it is doing, it is just printing hello world, for example. It is just doing that. Okay, now if you call it func, let's say if I call it, it will just print me, sorry, it will print this. Now it is printing none because it is returning, there is no return statement, so the default is none, right? So if I just print it, it will print hello world. Now what if I want to print this hello world in all capitals? So one way I could do is, you can just update this function to say something like this, right? It works. But what if let's quickly, just give me a second, dot upper. So what if instead of changing the code of this function, I want to add, like I want to allow this upper behavior on this? So how I could do it? You could do it with a decorator. So how to define a decorator? For example, yeah, for example, like how, so there the decorators come place. So how to define a decorator? Simple, it will be defined as a function. For example, def convert uppercase, name it something like this, and just here we need to define an inner function which is doing which is doing this. Okay, something like this, and which is, wait a little, okay, which is doing something like this. And how to run it? So I created this function, and how to attach it to our existing function is just to do something like underscore convert uppercase. So let's see what happens. What is happening? Okay, there is an error. Convert up takes 0 position, but 1 was given, but 1 was given. Okay, yeah, sorry, I need to pass this to here. Okay, something wrong. I have created a function which is passing this. I created an okay, sorry, instead of this I need to do right. Okay, so let's see how it works. Okay, something I must have missed something. Okay, so let's see how it is working. So for func I have created this, and this func is just returning hello world. Okay, now I have added a decorator which is convert uppercase, And how I have defined this, I have passed this function as a argument, right? And in there I have created an inner function where I am making some changes. Okay, so for example, what if I just do this, right, instead of this? So let's see what happens. So it will throw me an error because this string object is not callable, right? So you need to define it something like this. Okay, so this is how you can define your decorators, right? You can call the single decorator on multiple functions. For example, you have defined a function func something like this, then you define other function func1, let's say, and you attach this decorator on top of it. Okay, and here you are saying hello nation, for example, and now if you run it, it will also work. So basically you can have one okay, give me a second. It should need to do something like this, something like this, just to see. Okay, so if you run this, it will print you hello world and hello nation. Okay, so basically you can attach one single decorator on multiple functions. Okay, and you can also pass your arguments in this decorated function as well. For example, let's take the same so let's take this. So what if I want, so let's see, I have created a function func which will eventually call this, but yeah, let's say I have defined something like this, right? And this func, I am passing a variable x. So I am saying something like my name is x. Okay, something like this. I'm doing something like this. Okay, now I want to call it. So let's see what happens right now. It will throw an error because the name is not defined. Okay, while you are okay, sorry. Okay, so let's do it again. So here you see it is throwing an error. The reason being this name is not defined. Now the reason being because you have added this, but this name is not passed some anywhere else, so you need to pass it here. The moment you do this, it should work, right? Name, okay, sorry, we need to mention something like, let's say Paul. Okay, so this is how you can work with, like how you can pass arguments to a decorated functions. Okay, next we have, again, like we discussed about the arbitrary arguments and the keyword arguments. Similar, if you don't know how many arguments you are passing, you can simply pass it using args keyword and the quarks keyword. Okay, so for example, I am doing something like this, func slash args dot upper basically. Okay, now how do I call it? I'll create my function similar to this, and I'll just call it. So this will also work fine. Now let's say if I have one more, do this. For example, now I want to pass two parameters, let's say name and age, for example, and sorry, let's say I want to pass 25. Okay, so my name is Paul is list and my name is string age, right? Something like this. So if I do this, so this will work, right? But let's add one more, like location, and I pass here LA. Okay, and I'll add something like plus I live in plus, let's say, location. So here what I have done is I have created a decorator which is passing arbitrary variables, right? So no matter how many variables you pass, it will just convert everything to uppercase. Okay, so this is how you can work with like how you can pass the arguments in a decorator functions. Okay, similarly, you can create multiple decorators on one function as well, right? For example, yeah, you can add multiple decorators on one function as well. For example, yeah, okay, so for example, you are creating a function name, let's say def func, which is doing only, let's say, return a variable name, for example. Okay, and let me pass the name, and let's quickly call it func Paul. Okay, so if I run it, I'll get Paul, right? If I want to change it to uppercase, so how I can do it? Using decorator, I could create a simple decorator with something like this, right? And it will convert it to uppercase. Let me quickly do it. Okay, if I run it, I'll get, okay, I made a mistake somewhere. Yeah, I need to pass this parameter here. So once I do it, it will work, right? Now what I want to add something, my name is Paul. I want to print something like my name is Paul, and I don't want to change this function. So what you can do, you can create another let's say decorator, which is adding a greeting, basically add greet. Okay, something like this. So how you can define it is something like def, and this is how you can add it. So I'll do something like this, and if you run it, it will do something like this. Okay, so first it will call the convert tuple. So what I want to convert is, I want to convert this name to upper, it will convert it to capital Paul. Then I'm calling this add greet on top of it, and it is just returning something like this. Okay, so this is how you can add multiple decorators on a simple function. Now if so, preserving the function, so when you create a function, there are some metadata attached to it. So for example, I want to see the metadata for this. Okay, so for example, I do something. So if you see the function metadata, you'll see it is calling the function name is inner function, which is incorrect, right? Because the function name should be func. And if you want to see, like, if you can similarly see other metadata as well, dot and there must be more. So you see there are more, like annotations or something like that. That's how you can see the metadata. Okay, now we are interested in the name. So how we can preserve the function metadata? So what we can do, we can use function tools dot wrap. So for example, here where we are defining our decorator, I could just use something, I could do something like dot func. So basically what it will do, it will protect. So let's run it. So it will give, okay, we need to import it. So this is an, I need to do something like import first. Okay, so it is still saying inner func because add grid is called again, so you need to add it again here, because functions are being, two decorators are being called on top. Now when you run it, it will show you the func. So this is how you can preserve your metadata. Okay, this is again an important thing, which is like you don't want to, you want to have a correct documentation. So that's how you can preserve your metadata. Okay, so we have discussed what are functions, how we can define it with uh, positional arguments, keyword arguments, and things like that. Then we have discussed something called lambda functions, recursion, generators, and decorators. So quite few things we have discussed, and I think that's all for today. And whenever we come next, we'll talk about the other few things, which are not a lot, but yeah, this is a major, like this is a major chunk of Python that we have covered till now. And if you are following, I think you are in pretty good shape. If somebody asks you whether you know the language, so you can say that yes, you do. Okay, bye.